Hello, my name is Mohammed. I'm software engineer here at Exasol. Exasol is an in-memory database built for analytics. I am member of integration and product development team. Our team supports integration tooling around Exasol database with open source projects, frameworks, and also with technical blog articles or tutorials. And today I'm going to present you our Exasol Kafka Connector Extension. It allows you to import data from Apache Kafka clusters into an Exasol database. So let's get started. This is rough agenda for this series. I will give short introduction about Apache Kafka architecture. After that, I am going to describe our connector extension and some design decisions we took to implement it. Then I will go over the deployment and prepare the connector so that we can use it later. In this part, I am going to present until the deployment and preparation, and in the next parts, I'm going to show you how to import data from Apache Kafka cluster into an Exasol database. So please stay tuned. So first, let us start with brief description of Kafka architecture. Apache Kafka is a distributed streaming platform that is horizontally scalable, fault-tolerant, fast, and runs in production deployment in many companies. Of course, it has stood the test of time. The most common usage of Kafka is a central platform that allows to reliably provide data between different systems or applications. Here I will briefly describe how it works by mainly concentrating on three Kafka components: topics, brokers, and offsets. Apache Kafka topic is an abstraction that represents distribution of data over several partitions. Kafka stores each data record in the order of their arrival inside a partition. Additionally, Kafka assigns a sequence number, called offset, to each record in the ascending order inside a partition. For example, we have a topic named day that has 4 partitions. The white shapes represent the new data records, while the dark shapes represent already consumed records. But what are consumers? Well, consumers are users or applications that consume data from one or more partitions of a Kafka topic. These consumers are assumed to be unreliable, that they can fail, stop, or disconnect at any time. Usually, a set of consumers are abstracted into a consumer group. This helps when there are many different departments or microservices that are interested for the data of a particular topic. In short snippet on the bottom right corner, you can see that we create a topic with the name topic A that has 4 partitions. We also set the replication factor and some topic-specific configuration parameters. You can read more about these different settings in the Kafka documentation. One thing you should notice is that we do not define any schema when creating a topic, for example, column names or column types. In a typical Kafka installation, there is also schema registry service that registers and maintains a topic schema. Now, the Kafka brokers are basically the physical servers in the Kafka architecture. They hold partitions of the topics. Here on the picture we have 3 brokers, and they are responsible, usually called leaders, of a specific topic partition. I also mentioned in the previous slide that topic can have replication factor. It applies to the partitions, that they can be replicated to other brokers. This can improve the latency, but on the other hand, it increases the storage size of the Kafka cluster. Another important concept is the states of each record inside a partition. Each record in a partition can be new. For example, a producer produces a new record, or it can be consumed. A consumer have read or requested that record. And the record state can be committed, that the consumption of that record has been finished and reported back to a broker from a consumer. Then brokers will not give any committed records to the consumers in that group. But how does Kafka manage these states? There are 3 main approaches. The first one is that the Kafka cluster periodically commits the records after sending them to consumers, regardless if it receives an acknowledgement or not. The second approach is that consumer applications ask Kafka cluster to commit records inside a partition up to a specific offset. The final approach is that consumers themselves manage the offsets. That is, they maintain saved state and they know from which offset of partition they should start consuming the next records. So this was brief explanation on Kafka architecture. Let us continue into introduction of Exasol Kafka Connector Extension. We have developed a Kafka connector that allows you to reliably import data from any Apache Kafka topic. Users can run it as a SQL statement. The connector behaves as a Kafka consumer application and imports data in parallel from topic partitions. That is, once the import SQL statement is run, the connector starts multiple importers that consume records from many partitions in parallel. One of the main design decisions is how to manage the offsets of the imported data. Once we import any record, we do not want that record to be inserted into a table again. We need to commute the record offsets to make sure that the Kafka brokers don't send previously consumed records to new consumers. We briefly discussed 3 approaches to do this in the previous slides. For the Kafka connector extension, we decided to manage record offset states ourselves in the connector. We do this by keeping topic partition ID and record offset value pairs inside an Exasol table as a metadata. After the import, these 2 values are saved durably to the table together with actual topic records. The next import obtains maximum offset per partition from the table and starts consuming Kafka records after those offsets. So it only inserts new records into a table. I hope this makes it clear how connector works and how it maintains already consumed Kafka records. Okay, in the next section I will show you how to set up the Kafka connector. For the deployment we are going to follow the connector user guide. So let us do those steps. So we are going to go to the Kafka Connector Extension repository. You can find in GitHub, Exasol page and Kafka Connector Extension project. Here in the information for the user section, there is a link to the user guide. Let's open it. And we are going to follow mainly the deployment section. First, we are going to download the latest jar file. So for that, we are going to open this GitHub releases link. Here you can find the latest release. When you are watching this video, the latest release may be different than this one, but that's alright. And we are going to download this jar file. We are also going to download the checksum file so that we ensure that jar file is the same as it was uploaded. Let's download these 2. Now let us check that the jar file has a correct checksum. To do that, first I am going to go to the downloads folder and run this command. And provide the checksum file with a SHA-256 extension. As you can see, it returned OK, which means the jar file we downloaded contains correct checksum as it was uploaded. So now we are going to create a bucket in Bucketfs. Bucketfs is a simple storage file system for the Exasol, so we can store our connector inside it. Of course, you can read more about Bucketfs by going to the Exasol documentation, database concepts and Bucketfs. And to create a bucket, I am going to use the Exoperation UI, and I'm going to go to Exabuckets, edit default, open the ports, and create a new bucket. I'm going to give a name jars, make it public and give a password. Okay, we created a bucket in Bucketfs. And now we need to upload our jar file to that bucket. To do that, I can run the curl command. So here I give the Kafka connector jar and provide the bucketfs path for the bucket we just created. Okay, and let's confirm that it is uploaded correctly. And as you can see, our jar file is listed in that bucket. So next I need to create the connector scripts, and for that I'm going to connect to the Exasol database. I already did that. So as you can see, I'm connected to the Exasol database. Let's just confirm that it's running. Okay, looks good. And now let's copy these connector scripts and run them also. I am using DB Visualizer SQL client, so I need to put this markers. And similarly, I need to replace these placeholders. So for the bucket, we need to put the bucket name we just created. So it was jars. To do that, I'm going to use it was jars. Okay, I want to replace it. This one also. There was one more. Okay, place. Similarly, I need to also replace the version number. So let's also do that. 153. Okay, this also looks good. So let's run these scripts. Okay, that looks good. We did all the steps. So to conclude, I introduced Apache Kafka Architecture. I also introduced our Exasol Kafka Connector Extension, and we deployed the latest jar file to the Exasol bucket, and we prepared the connector scripts. Thank you for watching, and goodbye.